Okay, thanks. Yeah, hey folks. So today I'm gonna, cover my journey to Google DeepMind. Uh, I'll give you some background about myself, and then from there on, I'll walk you through all the stages of the interview that I went through in order to land a role at DeepMind. So before that, a little bit about me. Uh, So I'm a research engineer at Google DeepMind. My core focus is on AI for education, um, and I'm a core contributor on uh, projects such as LearnLM, Astra, um, and others. And I am the overall tech lead for the project Astra AI Tutor that Google introduced at I/O just a few days ago. So. Uh, Aside from that, what I also do is that I conduct a lot of interviews for DeepMind. So I'm going to give you, hopefully through this particular session, I'm going to give you some insights into how I think as well, and like what I evaluate in candidates when they are answering the questions that I pose to them. Um, and if you want to know more about my work, I'm not going to play this YouTube video today, but there is this video that you can look up uh, on YouTube from Google, and this is the work that I led at DeepMind, uh, uh, and it's essentially an AI. It's a multimodal agentic AI tutor that we are building here at Google. Okay, with that, that was a very brief introduction about my work, myself, uh, and a little bit of what I do. So now, with that, I'll move on to uh, my journey to DeepMind. So, uh, my journey actually, and I thought this would be like super. It would be super helpful to cover like some of my background, and especially if you are in your undergrad, there are some things that you can do in order to kind of some best practices that you can follow just to in order to kind of build a strong profile. So I completed my undergrad in computer science from India, and while doing my undergrad, one of the things that I did was that I took part in numerous research projects, uh, and the core focus area for these projects was the intersection of like systems engineering and machine learning. um, some of the projects were open source projects that were sponsored by grants from organizations like LexisNexis and are publicly used today, and available through the LexisNexis ML libraries. Uh, Aside from undertaking projects with professors, the other thing that I did was that I participated in multiple hackathons. And I think hackathons are a really good way of building up very good technical skills and like getting a good breadth of knowledge across different kinds of tools that exist out there, because while hacking you're kind of building a full stack application, coupling that with like some ML algorithm, and then you're kind of building a product end to end in some sort, and then you understand the different components that go into the product. So through by participating hackathons, some of the skills that I learned was in Android development, in cloud computing, machine learning, and more. Uh, and during my undergrad, I also had the opportunity to intern at places like Microsoft Research and uh, Morgan Stanley. Uh, Post my undergrad, after my internships, I joined Morgan Stanley as an analyst on the equity swaps trading team. Uh, Essentially, uh, this team was focused on building like high performance systems for for systematic trading. And some of the technical skills that I gained through this particular role was that a lot of development was in C++. So I learned that. I learned Spring Boot as well. And then there was, some proprietary trading databases that a lot of these banks use. So you kind of have to kind of interface between those, and therefore, through this process, I kind of had a good sense of, how to develop like good backend systems which are like highly performant and can support like low latency trading. Uh, at Morgan Stanley, I worked as an associate for about a year, but then I soon realized that it wasn't my calling because although the work was very interesting and there was a lot of like, systems engineering and low level optimizations that you end up doing in the job. I really wanted to do something in machine learning because I was really, really intrigued by all the progress that was going on in the field, all the cool applications that were getting built, and therefore, what I decided to do is that I decided to uh, leave Morgan Stanley and pursue my master's at Carnegie Mellon University in the United States. Now, at CMU, I enrolled in the computational data science program, and this is offered by the Language Technologies Institute within the School of Computer Science. Now, one of the things that uh, happened at CMU was that while I was studying, uh, I also, had the opportunity to kind of serve as a TA in many of the courses that I undertook. Some of them were in advanced natural language processing, multimodal machine learning, etc. And the good thing about being a TA in these kinds of courses is that uh, so in general, the way it works is that you take the same course, like let's say in semester one, and then in semester two, when you have kind of already gone through the entire course, you can apply for the TA-ship for that particular course, and then the professors talk to the professors, and they'll evaluate you. How there are some interviews in general to get the TA-ship, and then you end up getting the TA role. And the good thing about doing uh, good thing about working as a TA is that it kind of allows you to reconnect back with a lot of the stuff that you studied and kind of view it from the lens of someone who is tutoring, let's say, a new person, right? And therefore, what ends up happening is that a lot of people come to you with a lot of questions on, and then your understanding of that particular subject uh, develops even more because now you're not just like reading something, but you're like actively synthesizing all the kinds of problems that people are facing. You're trying to debug it for them, you're trying to solve them. So in a way, it ends up deepening your knowledge. So I think that doing this doing the TA-ship was like extremely helpful in kind of building some depth in each of the subjects uh, that I kind of took. Uh, and then another thing that I did was that I also took like so I also had a capstone project, and the capstone project at CMU was very interesting because this focused on the Alexa Prize Symbot Challenge. So the idea behind this particular project was that you had to build a simulator bot that could kind of listen to commands that are given in natural language and execute that commands in like a simulator environment. And the reason why this is interesting is because this was a huge part of, I guess, what stood out in my application to DeepMind. Uh, but essentially, what ended up happening was that the project that we were working on, there were many universities that were competing. And uh, in our case, like our team ended up making it to the world finals, and we were ranked like first when the beta phase was going on. So this was actually a pretty good experience because it also gave me like some amount, like some kind of insights into like, okay, how do I use the most cutting edge ML to kind of build like an AI agent that can do these tasks completely autonomously in a simulator environment, right? And then while at CMU, I also interned as an applied scientist at Amazon Science. So at a high level, this was briefly my background. I had about an undergrad and a master's in the field of computer science, and then I also had 1 year of experience working at Morgan Stanley. Um, Now, this is how it all began for me. Uh, So while I was interning at Amazon, there was this post that I found on LinkedIn from a recruiter at DeepMind. Um, and if if you guys know that DeepMind back in 2022 was a separate research lab within the parent company of Google, Alphabet, but it wasn't integrated with Google. And DeepMind was known to be extremely selective in the kinds of people that they hire. There were a lot of famous it was always in the news. I mean, if you know AlphaGo and other documentaries that have come out from DeepMind was the lab that yeah, I think beat the best Go player in the world, which experts had kind of thought it was a very difficult challenge back then. So they had a lot of it was highly selective, highly prestigious, uh, and also you know, in terms of like picking the candidates, whenever someone puts out a LinkedIn post, you don't expect that if you apply through that, you're going to hear back, right? So that was the same story with me as well. When I applied, I just thought I was applying for fun. So I just attached a copy of my resume, which was the latest based on my experience, and then I sent it without even thinking about asking for a referral because I kind of had assumed that yeah, I wouldn't get the job. Uh, but something nice happened, and much to my surprise, I heard back from the recruiter like 1 week after applying. And the process was that I had the recruiter set up an initial call with me. During the initial call, one of the things that we discussed was about like the interview process, uh, and the recruiter kind of briefed me about like what the interview process is going to look like, what are the different stages, asked me to provide like some my availability for the different stages and so on and so forth. And one of the things that you do during the recruiter call is you kind of like try to ask as many questions as you can just to get a better sense of like like what to expect during the interview process. So and I think this is like highly recommended because the interview process has changed quite a lot since the time I joined, and therefore your recruiter is like your best friend during the entire interview process. So make sure that you keep asking a lot of questions, uh, and they in most cases they would be happy to answer it. If for instance they can't disclose something, they'll kind of clearly tell you that they can't disclose something, but don't shy away from asking as many questions as you can. Some of the questions that you should ask is like, how much time will each interview be, what is the format of the interviews, uh, who is the interviewer. That is also an interesting question to ask because uh, knowing the interviewer, you can kind of like research their background. You can kind of know where their core work or expertise lies, and you can also like kind of like try to prepare really well in those areas because you can be certain that if there's if there's a interviewer that is experienced in let's say a domain X, they will ask in some form or the other questions from that domain X, right? So this is just a tip to keep in mind. But essentially, the process for me when I was interviewing, it had 5 different stages. In the case of stage one, it was supposed to be a coding interview and an ML interview. Uh, each of the rounds was supposed to be 45 minutes. Stage two is similar. Uh, In stage 3, you actually have 30-minute rounds with two tech leads. Um, and in stage 4 and stage 5, stage 4 is more of a like a behavioral round, and stage 5 is a team matching round. Now, uh, in this kind of template is common to most big tech companies. Sometimes you don't have a stage 5 round, but this is very popular in Google, where you do have a team matching round. In some cases, you might just join the company, and then you might be put into a team on and some sort, right? But this is how it works for Google. One of the things that you need to remember here is that each of the stages uh, are like elimination rounds. So what that means is that you can only go to stage 2 if you have passed stage 1. uh, and a criteria for, I mean, uh, this is true to some extent, is that it is like when we kind of conduct interviews, we have like a rating scale in which we have to provide feedback about each candidate. And we kind of have this rating scale where we want to say yes, no, and strong no. I mean, these are like 4 points, but sometimes the rating scales are different. But essentially, you kind of have to have like a strong yes uh, on at least one of the two sub interviews in that particular stage. So that's important. So that means you have to do like at least one of them really well, and the other you have to have a yes at minimum. If you get a no or a strong no on any of the from any of the interviewers, then it is very, very difficult uh, to progress. But that being said, exceptions do happen sometimes, and that's complete. It's just a part of the process. So there's no like hard and fast rule that this is how it works. But essentially, what happens is that each stage, there's a lot of candidates that are interviewing simultaneously, and after each stage, we pick the best candidates. We move them to the next stage. So, because of this, the process of hearing back after each stage takes about like 2 weeks. I would say like roughly 2 weeks for you to hear back after each stage. Now, what I'm going to do next is try to break down how I prepared for each interview stage, because I think this will be important if you are kind of trying to go through the same process. Now, in the first stage, you have the coding interview round, and the coding interview round at most big tech in general focuses on two important topics. One is data structures and algorithms. Uh, a recommended resource for solving a lot of these questions is lead code. In my case, the way I prepared for it is that I used to solve 2 to 3 questions per day from lead code. And because you have 45 minutes for this coding interview, out of which you can assume that 10 minutes, the first 5 minutes will be the introduction that you have with the interviewer, and the last 5 minutes are generally kept for questions. So if you take that into consideration, you can assume that you only have about 35 minutes for your coding interview. Taking that into consideration, it is very important that when you're solving questions from places like lead code, you time your solution. So the way I did was I timed every question to be 30, timed every solving every question to strictly 30 minutes. And I also focused a lot on solving medium and hard questions. So one of the good things about lead code is that it allows you to categorize and filter questions by the level of difficulty. And uh, you have like easy, medium, hard, and so on and so forth. So I generally focused on solving the medium and hard questions. Uh, Another technique that I employed is that I tried solving a question within 30 minutes, but that wasn't always possible. Sometimes, you take a stab at the question, but the approach you're trying is completely wrong, or doesn't satisfy like the time complexity or space complexity, and therefore all test cases don't pass. And therefore, in those cases, what I did was I flagged those questions, like I starred them, and I left it for a review, like for the next day. And the next day, I would come back, look at the same question, try another approach, because it was like I knew what I had tried the previous day. I knew what I'd failed, so I would try using a different approach to solve it. And if even after trying it the second time, uh, I couldn't solve it, then what I did was that I used to look at the solution, understand like what is the concept that was employed in solving the problem, what did I miss, and mark it for revision. Uh, and then this strategy is like really, really useful, because what you can do is that you after going through this process over and over again, you will kind of build up a question bank of revision questions. And these revision questions are really the ones uh, that that are going to be very useful, because you can expect, like at least in my case, most of the questions that I got in the interview ended up being some variant of the revision questions. And therefore, uh, you there is like some implicit transfer of like between what interviews consider as good questions and then the questions that you can't solve, right? So focus a lot on those questions, try to solve them, or at least review your solutions for them a day before the interview. Now, coming to coding interviews, there are certain algorithms that are absolutely that you absolutely must know, especially if you're giving an interview for big tech. uh, One of them is like, some of them are like breadth first search, depth first search, backtracking, topological sorting, binary search, union find, memoization, etc. So uh, these you can kind of hands down be sure that whatever question you get in your coding interview is more likely than not going to be based on these algorithms or some variant of these algorithms. So in many cases, you might have to apply uh, two algorithms in together, or like mix and match between algorithms to solve a problem. But these are by far the most important algorithms that at least I found when I was interviewing for most companies. Um, and in terms of data structures, you don't really need to know like very fancy data structures. I know like people talk about red black trees and like so many other different data structures, but you like knowing the basics really well is often enough. And then based on your like your practice and like your during your practice sessions, you kind of can naturally modify most of the basic data structures to conform to the constraints that are provided by the problems. But in terms of data structures, I would say you definitely need to know how to construct the basic trees, graphs like binary, n-ary trees, graphs, heaps, queues, stacks, etc. So these are the most important, data structures and algorithms I would focus on if I was preparing all over again. Uh, Next, what you have in stage one is you have an ML interview, and the first ML interview is generally an ML fundamentals interview. Uh, so, in terms of ML fundamentals, you can expect questions on math. So, in terms of math, you can expect like basic probability statistics, calculus, questions that are related to these topics. Probability and statistics are the most common, calculus not so common. And in most cases, it's the question is not like the interviewer is just like trying to see if you know some basics of using this or not, because that's kind of part and parcel of the job that you do as a research engineer or a research scientist. So that's what they are probing on. They won't really throw at you like some obscure theorem that is used in an international math olympiad or something like that. So they'll ask you like really basic questions in these domains. In terms of ML fundamentals, So this is this generally focuses on the very basics of ML. So you might expect like some example questions are like, what are optimizers, what is overfitting, what do you mean by bias variance trade-offs? And within these questions, what the interviewers will try to do is that, or this is what even I do, is I first ask a question like, what are optimizers? I try to gauge like what is the level of understanding of the candidate. Then I ask more targeted questions within each of them. For instance, if the candidate says something like, some examples of optimizers are Adam optimizer, stochastic gradient descent, I'll ask the candidate to go ahead and explain how Adam optimizer works, what's like the core concept there. Can you write down what the equation looks like? Um, and like how is it different from others? So what I do is, what you can expect interviewers to do is that they'll ask you one very simple question like this, like what are optimizers, and then they will kind of dig deep into each of these. um, so be careful of what you say. So if you are saying something, then you have to know kind of the theory, or at least know really well what you're talking about, because you can be sure that the interviewer will press you a little bit more on whatever you say. So prepare well in that sense. Uh, it's not going to be in terms of ML fundamentals. We're not looking for like really, really like some really, really complex problems. The problems are often simple. We're looking at how well you have understood your ML fundamentals, how well you know the and again, we're not looking for you to memorize the definitions, but we are looking to find like how good of an intuition you have for each of these questions. So one way to practice for these kinds of questions is trying to explain it to someone who doesn't know, let's say, machine learning, trying to break it down into such a simple, like a creating a very simplified explanation of it, explaining it to someone who doesn't know machine learning at all, and trying to convince them that this is the answer. So that's how deeply you need to know each of them. uh, Now, aside from MN fundamentals, one of the things that people then move on to, and again, nowadays a lot of the ML roles require some form of LLMs, but there could be other specific roles as well. Let's say like in image or something like that, or like video recognition or something like that. In those cases, you might have like slightly different questions, but let's say for what I've seen and what I also do right now is we generally move from the basics of ML fundamentals to sequence models, and we expect the candidates to know uh, something about like RNNs, like explain the different kinds of recurrent neural networks, explain the architecture of transformers, how do they work, what are the different components. So these are some of the questions that you can expect here. And like apart from these low level questions that test your understanding, another thing that has become very popular now is also asking some higher level questions about just how you train LLMs in general. So some common themes on which you can expect questions, especially if you're interviewing for like research engineer scientist roles, is um, what does like pre-training, explain some algorithm in reinforcement learning, quantization, etc. So knowing these concepts is super important, and you don't always need to know about the latest research, but having that kind of knowledge is always going to be a plus, because sometimes just for like if a candidate is doing like really, really well with the basics of with the all the fundamentals, knows everything about LLMs, uh, some of the things that we like to do is also ask a little bit about the latest research, just to check if the candidate is aware and is actively like following what's being done, what's being done in ML nowadays. So sometimes we might just throw a question or two out there about like some paper. So we don't always expect candidates to know because there's a lot of research that has been done concurrently. But if the papers are popular, uh, and if it has got a lot of attention in the recent past, then we do expect the candidate to at least be aware of it. Uh, and that actually, sets you apart. So that's the difference between getting a yes and a strong yes. So if you're able to know the fundamentals really well, you can answer almost anything on like LLMs, let's say, um, and you know the research, the latest research, then that would kind of automatically transition from yes to a strong yes. And this is all, and why I say this is important is because, just like you, if you know the ML fundamentals really well and you answer everything really well, there are 100 other candidates who also know the ML fundamentals very well and would also answer all the other questions very well. So, in order to stand out, having that extra edge is always going to be a plus to your profile. Now, after this, I think, so that was stage one. When I finished stage one, I waited for about, I would say, like, yeah, about 2 to 3 weeks to hear back. And then I heard back asking me to give my availability for stage two. And again, stage two had the same format as stage one. Uh, and in terms of my prep for this, I also followed the same format. But during, I think, stage two, what I did different was that I focused a lot more on lead code hard problems. And I think this is something that if you do enough problems on lead code, you will also realize that a lot of the easy and the medium problems become repetitive in some sense, because it's the same concept, same data structure, algorithm every time. It's just the wordings of the problem have changed. So you kind of like start seeing a pattern. And therefore, the lead code hard problems are still very interesting in general because many of them are different. They involve like dynamic programming, each time having some different concepts. Although over time, you also start seeing patterns in the lead code hard as well, and they also get a little boring. But that's what I did. And again, one thing that I learned from my stage one was that after I used to solve like a problem, the interviewer would ask me for the time and space complexity of my solution. So uh, in stage one, I kind of computed the complexity like on the fly, but for stage two, I also decided to prepare in this way. So this is, I think, super important and often overlooked. For every question that you solve, you should be able to tell what space complexity and time complexity your solution uses, even if it isn't the most optimal uh, solution. If you're able to tell this kind of information, it automatically stands out to the recruiter. Uh, sorry, to the interviewer. And another thing that I also try to do is I try to cut down the problem solving time to 15 to 20 minutes. That is mainly because if you finish your question, like during the interview, if you get a question and let's say you have 35 minutes to solve that question, but you finish your question like 15 to 20 minutes, then and you kind of run the code, show it to the interviewer, then the interviewer will ask you like follow up questions which add to your like brownie points for your application. So you might get one or two follow up questions which are very simple modifications to incorporate. And actually trying to like actually able being able to do both, like solving the basic question and then also as per the requirements that are given by the interviewer, being able to modify your solution to kind of fit the new requirements, uh, gets you a lot more. I mean, is like if you're able to do both, that's like a sure shot, strong yes in the case of coding interviews in most cases. So that is one thing that I try to do is so I try to cut down my solving time to like 15 to 20 minutes. And the other thing that I try to do was I also try to spend some time refactoring the code. Oftentimes when we are like solving questions in competitive programming, I think there's this tendency to write like code really fast where we don't pay a lot of attention to like the overall design of the code. And sometimes that kind of is bad, especially if you're doing especially if you're like use a lot of uh like bad coding practices, it kind of like stands out to the interviewer as like you're not, as you not being mature enough in your ability to write good code. So spending some time to clean up the code that you wrote, making sure that you follow the Python best practices, or like the best practices in any language, is also very uh, helpful, and it's a good skill to have. It's something that also clearly shows to the interviewer like the maturity of your coding abilities. Uh, there's this others round in ML that is also very popular nowadays, and this is what most big tech companies are also adopting. So the first ML round focuses generally on ML fundamentals, where we just ask you, uh, basic questions. The second ML round, we it's generally called an ML design round, and in this round, what we are interested in knowing is, if we give you a problem, like a completely open-ended problem, and we ask you to design an ML solution for it, with an end-to-end ML solution, right from pre-processing all the data to deploying your solution, how would you do it? So this is part of the ML design round, and an example of this question could be, design a video recommendation system on YouTube for recommending something in a particular category. So this is an example. Now, what's very important in this round, and this is often a mistake I see a lot of people that I interview also making, is do not jump directly into providing machine learning solutions. Like by that, I mean, don't tell me something like what model you're going to use to solve this particular problem at the first instance. You have to adopt like a more systematic approach, especially in ML design. So the first thing that you always start by doing is ask a lot of clarification questions. The interviewer will like intentionally provide a ambiguous question where there are many considerations. Like for instance, if I ask you to design a recommendation system for YouTube, you can ask questions like, so in terms of features, what kind of features uh, are available to us to use in the recommendation system? Could we use the text descriptions or the titles? Could we use the images? Could we use the video feed completely? So these are the questions that you ask in order to resolve all ambiguities, and this is what we all are expecting. And if you don't do it, it kind of again shows us that you know you're not thinking of this a problem from a professional standpoint. Uh, the next thing that you do after asking a lot of these clarification questions is then start by looking at the data. So like as I mentioned, you ask like you kind of like decide, okay, these are the features that you have available to you. How would you use them? Like, would you convert them into like there might be some text based features, so how would you process them? Would you use some embeddings? Would you use an LLM? Would you convert them into numerical features? So you ask these kind of questions, and you and basically start explaining to the interviewer like how would you take your data and transform it. uh, the other thing that is also very important and very critical from a design standpoint is you always need a baseline for comparison, right? And this is true for anything that you do in the industry. So whenever you're developing like an end-to-end product, uh, you have to have some metric or around which you compare the success of your project or something like that. So what is that metric? In the case of ML, it could be like, if let's say there was a problem that involved you improving the accuracy of some particular task, then some an example baseline for that could be like something that is selected at random. For instance, like let's say you, instead of using the features that are available in the data set, you decided that at random you would do you would predict like a particular class, then what would be the accuracy of such kind of a uh, such kind of a model, right? So that would be a baseline. So that's something that you also need to do. Establish a baseline uh, that is there for comparison. Uh, and then when you are approaching the problem, so when you have put together all these pieces, like you have started with all the data pre-processing, you have established an eval baseline, then come up with the most simplest machine learning model you can use for this particular task. Now, a lot of times people directly jump and specify like architectures that are like really, really complex. Uh, but that's not how we want you to think. Uh, don't, like, uh, don't try to over complicate things. Start off with something like really, really simple. For instance, like if it's like an image processing task, you could say that I'll use a very, very simple fully connected neural network or a multi-layer perceptron. I'll use that, and this is how I'll do it, rather than starting by saying that I'll use convolutional neural networks. So what that allows you to do is that it actually allows you to use the drawbacks of the basic architectures to your advantage, because what you can do now is by saying that by saying like I started using an I'll start with using an MLP, but there is this problem with MLPs, and therefore uh, I'll switch to using a CNN. So saying something like that allows you to also tell the interviewer something that you already know about, like the limitations of the simple architectures and why people used like a more complex architecture. So that is always a nice thing to do, because it shows that your justifications are sound. You know the entire background. You're not just like simply because people are using CNNs for that particular task, you're not recommending a CNN or something like that, right? So that's what I would recommend. Start with some very basic architectures, voice out what are the limitations of it, take the next architecture, again do the same process, say how it's going to, like what are the advantages over the previous architecture, what it allows you to do, and so on and so forth, until you build up to like a modern like solution. And then finally, another thing that often uh, interviewers ask you to do is they say that, okay, now we have this entire pipeline to process data, we have this model that we built to make predictions. How do you deploy it and scale it to, let's say, 1 billion users or 1 million users? So for this, uh, you can kind of like research like some strategies to do that, but you can basically think about like providing like some optimization strategies. Like in the case of machine learning, it would be quantization. So you could quantize your model, um, so that you don't really need this like a very large number of GPUs or TPUs to host it or something like that. Uh, so that is like one, but there are many other strategies. And then what you would also, one another thing that you might also expect in the deployment phase is that they might also expect you to tell you like some metrics of like how would you make sure that whatever solution that you have developed, through this entire process is actually achieving the intended outcomes in terms of like the users are actually benefiting from it or something like that. So for that, you can talk about like some metrics that you would collect from the deployment environment, like how many users are using, how the users are using it. So these are some things that you can talk about. uh, and yeah, again, the internet has a lot of resources on ML design. So uh, you should completely look some of them up. Look at how they approach the problem. I think there's a lot of good resources that are available. Then coming to the tech lead interviews. So in the case of tech lead interviews, what generally happens is you have people with a lot of experience that are talking to you and evaluating like your background. uh, and this is more about looking at the past projects that you have done, uh, and your past experience. Like if you have worked somewhere before, and you have done some project in that company, uh, you know till whatever level of disclosure you can disclose. People are just looking, people are not interested in like the exact specifics of that particular project. Like they, I mean, we're not looking for someone to tell us confidential information about like what metric improved. Like we're not interested in like telling, like people telling us, okay, this was the initial revenue, this became the final revenue after the project. We don't want that kind of information. Rather, what we're interested in knowing is what was the technical complexity behind the project. uh, so you can be very generic in your answer, not so as to not disclose anything confidential. You can refer to databases as you can kind of like mask away a lot of the names that people that are used. Like you can just refer it to as some generic database or something like that, and you can just say that I worked on this particular database. I made these changes in the tech infrastructure, and then these were the outcomes, and so on and so forth. Like, uh, so what we are really evaluating is how did you, what was the technical complexity of the projects that you have worked on, um, and like how much of them do you know in depth. So we really want you to own the projects that you have worked on. If you haven't contributed much to that project, you will very easily, and you try talking about that project, you might very easily be caught, because asking follow up, like we always try to go deep. Like if whatever you say, we try to push a little bit and query a little bit more into that. Um, so one of the things that you need to be sure of is whatever you say, try to give like some clear justifications for every decision that you make. And then in terms of impact, you can say some things in terms of latency. You can say like, doing this improved like the latency by so and so much, accuracy improved so and so much. Uh, even without giving the exact numbers, you can say like, um, you can be very kind of like generic about it, and just say like, this happened. uh, but but what's important to note here is just the technical complexity and how well you know that project. So don't so talk honestly, don't over exaggerate. uh, uh, and then you yeah, one of the things that is like super helpful for this particular round in general is asking your interviewer who your like asking your recruiter who the interviewer will be before the interview. So this is actually a good opportunity to kind of like, if the interview if the recruiter tells you, what you should do is try to look up their profiles on the internet, try to see what their past research is about, try to read up on a few of their papers. So this is also something that is useful. uh, like especially their more recent papers, because that's always like fresh in their heads. So try to read a little bit about that. And then when you are doing your interview, because this is more like a conversation that you have, uh, try to like, if there are any projects that you work on that kind of intersect with their work, try to emphasize on those projects, try to tell them a little bit about that. Uh, and that will kind of build a natural connection between you and the interviewer. uh, However, you must note, and this happened to me in both my technical lead interviews, is that I asked the recruiter who my interviewer would be. I prepared to, meet that particular interviewer, but at the last minute, the interviewer changed. So be completely prepared to talk to a complete stranger. So there's no guarantee that the same person is going to interview you. This happens all the time uh, at Google and other companies as well. Uh, Finally, you reach, after you have got through those technical rounds, you have the people and culture round. And in most cases, this is a getting to this round is a very good sign. Uh, and here they're really looking for your non-technical, and like your soft skills, right? Like how do you handle ambiguity? How would you function in a team environment? So there is this really nice strategy that people recommend. It's called a star approach. I don't know if I think most of you should know about it. Uh, is that you kind of like use this approach, like the situation, task, result, and action. So you first, like, start off by describing what that particular situation was. Then like what was the context behind all the problem. Then you describe what the problem was. Then you describe what action did you take to solve that problem. And then finally you kind of describe what the outcome of your actions. So this is something that a lot of people use, and this is a good way of approaching it. Another thing that to keep in mind is you also would like to know, at this point, you also need to know or have researched really well, like what the company is doing, what their values and mission are. And aligning your answers based on this is like super, super important. Like in the case of DeepMind, I mean, you might get a lot of trick questions, like in this case, like uh, questions would be around like, do you think we should have artificial general intelligence? Is it safe? And these are like trick questions. So like you have to like really, really before answering them, just like think a little bit and answer some things that are, and often choose like a diplomatically moderate approach. Don't go to one extreme of it and say that this has to be done or this does is should never happen, because that's going to like that's going to like raise some flags with the behavioral interviewers. Um, and this is also a good opportunity to know a little bit about the company's culture. So you can ask the interviewer things like how do teams and deep like how do teams in this particular company they function. Um, how exactly what are the working hours, when like what are the some questions like that, like how do people collaborate, uh is it online, is it offline. So this is something like, for instance, in my case, when I joined DeepMind, majority of the team was in London. So one thing that I learned was that there are like these golden hours in the morning at like between like 9 a.m. to like 11 a.m. PST, where both London and the Mountain View offices are kind of awake. So that's the time where any kind of meetings between the two offices, between the people in the two offices happen. So these are some interesting things to know. And then finally, what you get is the team matching interview. And in the case of team matching interviews, what you have is you um, often end up having one or two matching interviews. Uh, the format is very similar to tech lead interviews, but in this case, the interviewer is not evaluating you on any scale. They're only looking for a mutual match. So essentially, this is like a good opportunity for you and the hiring manager to look for like a mutual fit. So if you, for instance, feel like whatever past experience you have, whatever work you've done aligns really well with the hiring manager, you can kind of like indicate towards the end of the interview, that there's a strong match. If you feel like, this is not aligning with the hiring manager, then you often are offered like a chance to interview with another hiring manager. Um, but I would also like to point out that this liberty that you get shouldn't be exploited, in the sense that if you keep rejecting hiring managers, you will it's also not a good idea, because you might end up getting ghosted on the platform, and then that is not something that you want to be, a position that you want to be at. So matching with the first one or two managers, like at I would say like go for at least two hiring manager interviews, and then between the teams pick one. Is always a good strategy. Like, don't keep asking, because people don't have a lot of time in DeepMind to keep conducting interviews, and therefore it's kind of important to know that you are kind of respectful of their time as well. Um, and like this is just some additional interview tips. Now, as part of the interview process, you will feel nervous, you will feel anxious before the interviews. It's perfectly normal. Everyone feels that. uh, you also have this imposter syndrome when you join these big tech companies. But one thing that you one thing that you should always keep in mind is nobody knows what they are talking about. Use that as like your motivation. So whatever you know it like, yeah, and whatever others know, they know. Don't worry about like don't worry about feeling like an imposter and stuff. Like just focus on doing like good work. And oftentimes in the interview, you will have like the first few minutes of the interview that are spent in some small talk, like asking about your name, your university. So use this time to, like, calm down your nerves a little bit, to start talking. Don't be afraid, uh, to kind of like voice, like, actively, participate and talk with the interviewer. So, and again, like, don't view these interviews as, some things that will decide the fate of your career or something like that. uh, you will They are more like learning experiences. So acceptance, rejection is all part of the process. uh, Try to participate in as many interviews as possible. That actually builds a lot of like learning experience for you, and then that actually helps because you often know things about yourself, uh, when through an interview, that you can kind of work upon for your next interview. um, and some things that often happen in these interviews is that the interviewers will drop like some, like, let's say you're stuck on a problem, in a coding problem, or like, let's say, in an ML question. The interviewers will often try to give you like some hints, and try to, capitalize on those hints, because that's how the interviewer is thinking about it. So if you can actually from that hint build up upon the solution, that's always a good thing. um, there's also this funny enough case where sometimes the interviewers might also make mistakes, and that happens all the time. Like, it's more common than you think, right? So interviewers again are not perfect, right? And in this situation, a good way to deal with it is to, you know uh, stay calm, try to, engage in some discussion, and don't kind of like go into this confrontational behavior and try to tell the interviewer that, hey, like, you're wrong, or try to prove that they are wrong in some way that is sarcastic or something like that. Don't try to do all that. The interviewer is your future teammate. Just try to build rapport. um, and the way to do this is try to approach this problem solving collaboratively. At the end of the day, the interviewer should also not feel offended with like your tone and stuff. So try to, like, be a little mild and like the way you speak to them as well. Yeah, by that I don't mean like, by that I don't mean like you have to not, actively say something. If something is wrong, don't kind of like support that, or like say something like, hey, yeah, this is how exactly we should do it. Try to offer your perspective and your solution if it's better, and in a way that is non-confrontation. uh, and finally, how do you build a research profile, in order to, qualify for these kinds of roles? One thing that I would like to point out is, when you're creating your resume, right, that's like the first step in most of these interviews, right? Focus on the quality and not the quantity. So don't so if you have put like down projects in your resumes, we're not interested in uh one line projects, I mean, or like 5-word descriptions and 100 projects in that resume. We are not going to read all the 100 projects that you have listed down. uh, Rather, what we want is for you to cherry pick, um, like, let's say, your top 5 projects or top 3 projects. Describe them concisely, but in a level of detail that conveys like some strong technical uh, expertise in that particular project. So do that. Get involved in research. Try participating in research projects. So there's a lot of projects that are happening at universities. Reach out to professors, see if you can collaborate on some of them. I mean, a lot of people often welcome collaborations, and they have a lot of work. So if you can work with any of those professors or other professionals from the industry, on some research projects, that's always great. Try to get your work published. Look for like conferences, journals, uh, and even if you don't submit to peer reviewed venues, what you can always try to do is whatever research that you're doing, you can always try to send it to archive. So that's a really good way of like adding to your profile, and then it's a good way of iteratively building up on your research. Stay informed, like keep up with whatever is happening in the ML world or the other world in whichever domain that you're in. Um, and try to follow like all the uh, like the good researchers in on these various social media platforms, so that you know about like the latest work. Also try to look at Google scholars of many of these people. They have like most of their research papers up there. uh, and Now, another thing that's important is that whatever projects that you do, understand each and every aspect of that project. Know that during the interview process, we will really, really grill you to find out whether you actually did that project, or like how much did you contribute to that project. So, we really want to look at projects in which you have been the core contributor and you were kind of very instrumental in the success of that project. So when you're writing a resume, also try to highlight these kinds of projects. And yeah, I think those are like the very general guidance. So with that, think i'll I'm happy to take questions that you have. Thank you.